Okay, so in terms of low-level API design, what are we going to do? What should we try to avoid? So one of the first things we want to avoid are long parameter lists where the parameters all have the same type, because this makes it really easy for the developer to transpose two different arguments in a way that makes it for easy errors to be introduced into a system. All right, so let's take a look at a concrete example of this. So say we have an add user method. All right, so imagine we have this method, right? Add user takes last name, first name, initial, username, and email, and they're all strings. And as a developer, you know that when you encounter this method, you're going to forget what order these parameters are supposed to be in. And it's really easy to imagine that you'd send the first name before the last name, or you'd skip the initial and put the username in that field, right? In that parameter. So you really want to make sure you get this right. So one of the easiest ways to deal with this is to change this to use more well-defined types, right? So we can instead take a user object. And in this way, we can transform this long parameter list into something that the user can actually interact with, right? So now this user type will have a well-defined set of fields within it that they can set in a named fashion rather than just providing a comma-separated list of strings. And they can build this properly and then pass that to add user. So this is one way that we can design an API that is much more easy to use. The next low-level API design goal is to return descriptive objects. So often when we're building our systems, it can be really tempting to return primitives and rely on the client to parse those primitives in some way, right, so that they can understand what those types are. So we want to avoid that. So let's take a look at what that means. All right, so from our example before, right, you could say, just take the get user example, right? So we have get user data. So imagine we have a get user data that returns a string, right? And this method has a piece of documentation that says, hey, this returns a string with a specific format. So what this method is saying is it returns a string that is the first name, last name, initial, user name, and email, all in one big long string separated by commas. And it relies on the user of the API to parse this string to make sense of what this data is. But what this does as the API producer is it ties you to this format going forward. But what happens if someone doesn't have a middle name? Do you have an empty string or do you just have a gap? What happens if someone doesn't actually have an email? How do you handle these cases? So what we can do instead is we can transform this to return a descriptive object. So in this way, the client of the API can just say, oh yeah, I'm going to get a user back. I can inspect the user object. I can see what all those fields are, and I can deal with that appropriately. It also makes it easy for the API producer to go and say, hey, I can add new fields to this user object if I want to. I can't take any away, but I can add new ones, right? And that can give me flexibility going forward. It also makes it a lot easier for me to document because I can document the individual fields within this object rather than just having to add more detail to this string here. Right? So as much as possible, we want to return descriptive objects, and that can make it easier for people to understand and use our APIs correctly. When we design our APIs, we also need to think about how the API consumers will interpret the results that they're getting back. When we do that, we want to think about what are they going to be doing to that result object. So if we're returning a collection, it's often tempting to return null if there's nothing in the collection. But we want to avoid that as much as possible. So this piece of low-level API design advice is called avoid exceptional returns. So let's take a look at a concrete example of this case. So what this says is we have a method called getUsers that returns a user array if there are some, or null if there are no users at all. Right, so let's think about why this is a problem from a client's point of view. So let's take a look at a concrete piece of code. So in this code snippet here, right, if getUsers has users, it will return a length, an array of some length, and console.log u.length will print out the length of the array. But if there are no users and it returns null, this will actually fire a null pointer exception and will fail. So what every client of this API would actually do is they'd add a guard around the U result so they check it before they try to print something to screen or to use it for something else. Right, so they'd add this guard, and this is just boilerplate that all clients of this API are going to have to do. Right, so when you think about our APIs, we want to avoid this as much as possible. We want to avoid treating these exceptional returns in this type of way. So the easiest way to do that is just not return null, right? If the result is empty, just return an empty list, right? And that will solve our problem. And we see the same problem with strings as well, right? So if we were to return null instead of the empty string, if we ask the string for its length, we'll also get null pointer problems, right? So we want to avoid that as much as possible. So really, we need to think about the exceptional circumstances around our return types really carefully from the client's perspective. When we're designing our APIs, we also need to handle exceptional circumstances in a robust way. And one thing that we need to keep in mind is that when we encounter exceptional circumstances, we need to communicate what went wrong to the client of the API. And the reason we need to communicate that information is so that they can recover if possible, or if they're using the API incorrectly, they can learn from the error and improve their code. Right? So we need to make sure that we handle these exceptional circumstances in an effective way. So let's take a look at a concrete example. So let's look at an explicit error message that could be thrown in code. All right, so here's an exception that could have been thrown by an API, my internal error, message internal error. Now, this message isn't very descriptive for the user, so they're not going to want to know what's going on. But also, my internal error exposes the nature of the internal implementation itself. And this is something that frequently happens when we encounter exceptional circumstances, that we start to leak the details of our internal implementation through our API via exceptions. And we want to be really careful to make sure this isn't the case. At the same time, though, we want to help the user of this API to use it correctly. So a refactored version of this API might look more like this. So in this exception, when we get this back in this new error, right, we don't have this information about the internal error, it's just a generic error. It provides this code 215, which, to be honest, as a developer, doesn't mean anything to me. But when I talk to the API producer, if I have a problem, I can say, hey, look, I encountered error 215, and they can provide more information to me. It also provides a more useful error message, right? So rather than saying internal error, it gives me a hint about what I've done wrong. It says bad auth parameter. And finally, and this is a really nice property of great APIs that you'll see on the web today especially, there's this info link at the bottom. It'll say, hey, for more info, see dev.foo.com/e/215. It's the error code that we have here. And there'll be a web page there that describes the error and either how we can fix it or how this has arisen. Right? So it gives us more information as the developer so we know what to do going forward. Right, so when we're handling exceptional circumstances, we really want to make sure that we're not leaking internal details about our abstraction. Right? We don't want to have a leaky abstraction via exceptions. And we want to help the developer who's encountered these problems overcome them within their code. Okay, so there are two final low-level design principles that are really important to keep in mind. So the first is that we want to favor immutability. Now, we talked about immutability earlier, but it's really key in this context as well, because we want to make sure that when we return an object to a client of an API, any further changes that we make to that object won't be reflected in the client's copy themselves. And also, we want to make sure so that the clients can't mess with us either, right? We want to make sure when we give an object to a client and they modify that object, it won't change our internal representations as well. Right? So favoring immutability is really key for for enforcing that separation between the API producer and the API consumer. And the final piece is that we want to make our code as private as possible. Because when we create an API, if we expose any part of that surface to a client, they will start to use it. whether we've documented it or not, and whether we intended them to use it or not. So if we don't want clients of our APIs to use them, it is really, really important that we make them private. And this is fundamentally important. No matter what you do, people will inspect your API service and they will use anything they can get their hands on. So unless we have a really important reason, a well thought out reason for making something public, it should always be made private. And this is something that we should have in mind right from the get-go. Right? The default visibility on all members within our systems should always be private when there's a chance that some external customer could have access to it.